So it's Wednesday and we've got a Cybernet EasyCom ZX1 emergency kit here. Last time we did one of these, the mag mount area was a bit on the corroded side. I did my best with it, and we had the worst range we've ever had using the provided aerial. I think it was 4 miles on one of these types of sets, whereas the Maxcom 7E was just like having the mobile in the car. And you'd have thought that with it being Cybernet and Cybernet being a component and major manufacturer at the time, now making solar panels, you would think that it would work better than that. International viewers will recognise this as the General Electric help. Yes, that was an emergency set for the United States. So clearly it will have the same kind of casework, and obviously totally different inners with this being FM only for the UK. I've never had an instruction book for this. I bought this off eBay, paid far too much for it, 35 quid plus post, but I wanted to have another complete set in nice condition just so we could see the range of one in good nick. I've not got an instruction book with this. I don't know if it ever had one, but if someone has got the instruction book and can do a scan, well, we'd be very pleased to receive that. So you get the mag mount aerial, which is in lovely condition. You get the cigarette lighter plug, which apart from a bit of a splice in it is fine, and we get the radio itself. So we'll go through the service procedure on that. And we've got one of these in for repair from a customer as well, and he has a major VCO problem. And after I've done this video and behind the scenes, I'll be just taking some voltage readings with no circuit diagram. We've got no nothing, so having another one handy may help sorting his problem out. We can set the transmit to work on his, we can set the receive to work on his, but not both. So I think there's a capacitor change value somewhere in the VCO, which is wax filled. So Mr. Chippy will no doubt enjoy getting the wax out of that. Now then, all I've got to do is get this knob off. I do have exceptionally strong fingers as a church organist, but this one is eluding me. I don't like to use force on these things, but at least it's my set and not a customer's. I could do with a rag under there, and we'll see if we can get it's a bit naughty, this. Anyway, I did it without marring the finish, and that's what it's about. Oh my goodness, serial number 007. How impressive is that? This must have belonged to James Bond. Oh, we'll zoom in on that. I'll just stand up and make sure I can see that in the monitor. There we are. Serial number 007 with a 21 in front of it, and I'm Tango 21, aren't I? Wow! God, I bet you talk to Scaramanga on this. So you get a a half decent sized speaker, which is more than you get in most mobiles today. You just seem to be buying pointless features on most current sets rather than actual performance. Right, so the first thing we're going to need is to plug this into the test equipment. At least the speaker's not hidden, so we can gain access to the speaker for doing the Cynad test. And what I need is the RCA and Motorola to SO239 adapter. You know, when Tandis were around, they used to sell these for £1.79. Wish I could get them for that now. Now these will be a 12 volt set, so I must take heed of that. Yeah, it says so on the bottom. You've got high-low power on the bottom, in line with the MPT 1320 UK specification at the time. So we use the power cord provided. It does have a fuse in it, and it's 2 amps, and Mr. Chippy checked that when he opened the mail. So we're going to set the power supply to 12.4 volts. If I don't get 4 watts at 12.4 volts, the maximum we're going to go to is 12.8, which would be a fully charged 12 volt battery. This was last on 37. When my late mother was alive, that was her favourite channel. We didn't use 31 in those days. Okay. So we're going to hope this is on frequency. Without reference to a manual, see what we can see. The VCO is under there, so we have to take that board out to get to it. So the transmitter lineup is an interesting one. It's not that obvious. I mean, it looks to me like we've got there and there as adjustment transformers, and then nothing else in the PA. It's quite unusual. And we don't often get a transformer like that in a transmitter, so I don't know. That looks like we're going to have the... You know, is that the detector? Or is that the detector? I know this board's not used in anything else that I'm aware of. They're not very common. They kind of... I think they appeared about 1985. They kind of missed the boat from the 1981 legalisation of UK CB here. And... oh, I don't know. We just didn't see many of them. This is... I've got the customer repair in right now, which triggered me to buy this. And I own another one, which is in storage. And now this one with the better case and the outer sleeve. But we just don't see them. Right. I'll go into picture in picture. And I can actually see it's come up on the monitor, which means nothing. Let's go into transmit. I'll go in the 3 watt range because I'm not expecting it to blow the meter off. And the radio is doing virtually just 2 watts. So let's see what happens when I adjust that coil. Well, that has peaked. So it's doing 2.2 watts. I'm going to put the receiver in because I want to play with that, and I need to know whether it's transmit or receive. It's in the transmit strip, but then I can see a single inline IC, which could be the IF subsystem. So I'm going to use crocodile clip to put the positive end of the speaker input for the test gear, yeah, at least that one, onto the test equipment, because it's getting its negative through the chassis of the radio, so we're fine. So what we're going to do, I'll put the oscilloscope on, and I want to see whether that's the detector, that little coil there, or whether it's something to do with the transmitter. So we'll just select that. Take the bench light off so people can see the oscilloscope. I'll just pop the volume up a fraction. We'll just see whether that is the detector. Yeah. And it's way out. So that would have been lousy receive. So that's sorted that problem out. Good, we'll go back to the bench light and we'll go back to what we were doing. Turn the volume down. So what have we actually got? I just can't see any further adjustments with the transmitter. I mean, on some sets it's very poor practice, but the adjustments are by adjusting the fixed coils. But you've got the danger of having the coil stretching screwdriver expert, and I'm certainly not going to be one of those. But it's possible that that's how they're doing it. Certainly with the Maxon radios, they are an adjustment point, which I say isn't good. It has to be done in conjunction with the spectrum analyzer. So because it has a bar graph meter, we're clearly going to have adjustments for that. So we're going to have deviation for transmitted audio. We're going to have transmit bar graph if it has a true RF reading meter. Does it have a squelch adjustment? Well, I would think, before we carry on further with the transmitter, I would think that's going to be deviation because it's up by the VCO. So we'll get the little oscillator out. We'll go into, make sure we're set. Oh, it's going to do that, is it? We'll just disconnect the speaker. Go into transmit. And there we have 1 point something deviation. Wallow. Wallow. Well, it's not doing that. So we've got one down there. Nope. We've got one down there. which that tool doesn't reach down. And that tool doesn't reach down. And that's the wrong kind of end. We're going to have to take that board out. I'm going to turn the racket off while we do that. You don't need me to tell you what a faff these kind of things are. So this is what we think we're trying to get into just there. So we'll put the oscillator back on. It is, it's deviation. Wallow. Wallow. It's just slightly high. Let's try it there. Wallow. 1, 2. That'll do. It's about 2.4. I prefer it to be 2.2. Okay. It's a bit of a faff with the way the microphone is. So while we're in the VCO, which as you can see is full of wax, and where the snag lies with the other one, we'll do the frequency. If it's got a frequency adjustment. Because you wouldn't expect the frequency adjustment to be in a wax area, because it's just between 2 pins of the synthesizer IC. That could be transmit VCO adjustment. So we're going to go into transmit again. We'll look at the frequency counter on the test set. Should be at 2779125. It's slightly high. It may not have a frequency adjustment. So I'm going to be very careful adjusting this. That's VCO for transmit. So that's the last. That's not something to touch. So there is no frequency adjustment, and that is fair enough. And now we know. So we've got another. I'll just pop that back. I'll check it works on channel 140. I think I'll put the screw back as well. So although there's a hole in the display board, it doesn't line up with the preset. And so you're going in at a bit of an angle, and our tools weren't long enough to get to that. So we're going to have, I'm expecting transmit meter. So let's see if we can find transmit meter. It could be that one. Wallow. Oh, it shows, I'm not going to say modulation, but that's very, very unusual for an FM set. So, is this the adjustment for it? Wallow. Wallow. It is. That's the adjustment for the wallow. Right. Oh well. So that covers that. So I'm going to have to hop about a bit here. So let's see. We've got S9 on the signal generator. So we'll see. And how's this calibrated? It just says minimum and maximum. Let's see whether we can make the receive meter move. So is it this one or the next one? Isn't that one? How strange. I'm going to uncalibrate this just in case it's receive as well. It is. Okay. So I want that reading 3 bars and not 4. So this is the receipt. It's just the meter in general, and transmit just happens to be calibrated somewhere near Warlow as you talk. Okay, so you set it on receive. So I've got 3 bars for S9. So if we move the signal generator up to what would be plus 30 signal, we're getting further up the bar graph. That's a bit fine between those two, but we can adjust it. Excellent. Okay, so receive, which is also transmit. So what else are we going to have? You're not telling me one of these is transmit power, because it wouldn't work like that, I'm sure. No. So it leaves us with squelch. So what's the other one? Let's see which is squelch. So I've got that right on the threshold, so we'll have a twiddle. So that low one is squelch. You know what that is? It's just dawned on me. It's going to be low power adjust. So we'll just put the radio into low power. It should be something like 400 milliwatts. It's 210 milliwatt. It is. It's there. We are. So now we've got 400 milliwatts on low power. Ah, so low power and squelch. We're getting there. I'll go back to high power. Yep. So now it's cooled down, it's doing 2.3 watts. So I'm going to do that, which I don't like doing, and that's fiddling with coils. Yep. Power's going up. So that's just a whisker away from 3 watts. How bizarre is this? So that's it, about 3.3 watts. And I'm not showing you the meter. Let's try again. So we're about 3.3 watts. So I go on the 3 watt scale. It's now banging across. So I'll have one final check that that's as good as we're going to get. And I will check it with the spectrum analyzer, even though it is an emergency set. see what we get. Mind you, I haven't got a probe on that at the moment, so you're not going to get anything. Let's try again. We'll go over to the spectrum analyzer. So we've got the fundamental frequency there. So I'm going to dial in 54 megs. We'll put 55, somewhere like there anyway. What have I pressed? Okay, so there we are. Oh! Looks a lot of that. So we'll press the measure and peak. Oh, it's 55 dBm. That's absolutely fine. Minus 55 dBm. That's fine. Oh well, cleaner than we thought. Right, we'll go through the receiver. So what we brought the transmitter up from 2.2 watts to 3.3 watts. So yeah, it's 30% increase, and we should get the full range of our 6-mile test route. Which I must always say is a difficult route because it's the wrong side of a hill and in a deep cutting through rocks. There's a kind of cliff edge between us and that test road. So well, I think we should get the 6 miles on this kind of power, and with it being as clean as it is. But it's certainly a huge improvement from 2.2 watts as it was presented. So let's see where we are with the receive. So we'll go into I'll turn the spectrum analyzer off. We're done, and we'll go into the cyanide meter, which we'll plug back in. I say plug back in, but crocodile clip back in. So we did the detector, which was there. Now we're going to go through, this will be the front end, and there'll be the IF. Oh, at the moment it's not that bad at all. In fact, it's very good. It's 0.4 microvolts for 12 decibel cyanide. I mean, this isn't a fiddle with set, it's quite clear. There's no adjustment there whatsoever, or any improvement. We'll just do these IF ones. If I can get that to read, that is. Okay, where are we now? Yeah, there's no difference at all. It's 0.4 microvolts. So well, so we did the only thing we've done is we've improved the discriminator detector, so it's going to be louder and it's going to be clearer, because it would have been a bit garbled with that as it was. We brought the power up from 2.2 watts to 3.3 watts. And we've calibrated the low power to 0.4 watts, but because I'd been fiddling with those, we don't know where it was in the first place. So that's it. So there is no frequency adjust, and to recap, that's the meter in general through that hole. The one, no, that's the meter in general. The one through the hole's deviation, low power set, and squelch preset. We'll just need to check that we've got the squelch right. So we'll just put this into looking at the squelch. There we go. And I'm going to set that to full. And what we're going to do is advance the signal generator until we get to 100 microvolts, and hopefully it will come in at that. So 3 microvolts, 10 microvolts, 30 microvolts, 100 microvolts. It's not coming in. It's coming in at 300. Again, I fiddled with it, so let's get that set right. That is now set right, and it's coming in at 100 microvolts, which is S9 equivalent. So we'll look at it at the sensitive end, and we'll switch the signal generator to standby, turn the squelch down, that's threshold, switch the signal generator back on, it's parked at 0.3 microvolts. So it's coming in at just under 1.5 microvolts, we could say 1.45 microvolts, and the squelch is coming in again at 1.1 microvolts. So it should be sensitive enough for scratchy corner, etc. So not really a lot there. So behind the scenes, we're going to later take this apart again and do some voltage measurements, but we will do an on-the-air video. I'll just plug it into the aerial and see if anything is happening out there, which it won't be. Right, we'll put the knobs on in hopefully the right position. So that's there. And then we can put this on in such a position that it also shows the right channel with the pointer as well as the display. There we are. So I'll put it on the aerial instead. Well, I'll tell you what, this is actually a set that was working, you know. Buy it off eBay as, well, it's untested, isn't it? Most people don't have the foggiest, though there are some very interesting adverts. I know nothing about CB radio. And you go back on their previously sold lots, and they've all been CB radios, and you know, but they know nothing about CB radio. Great. Roger. They'll be 30 odd miles away. Okay, so there we've got the stupid echoes. How can you have that on? So what more can you say? We've got Cybernet ZX1. Its serial number is 007, which makes me feel very special. And we'll do an on-the-air test later on. And hopefully this will help us with the voltage readings to fix a customer repair with a swine of a fault in the VCO. Thank you for watching.